Hello everyone, myself Hiren Patel, associated with LJ Institute of Engineering and Technology. So in this current video lecture series, we are studying subject of Physics Group 1. So today we are going to start a new chapter, laser. So laser stands for light amplification by stimulated emission of radiation. So in today's video, we are covering the topics such as introduction to laser, properties of laser, principle of laser, and at the end we will learn the difference between spontaneous emission and stimulated emission. So let's start with introduction to laser. So what does laser stands for? So what laser is an acronym that stands for light amplification by stimulated emission of radiation. Here the principle behind the working of laser is stimulated emission of radiation. So lasers are essentially highly directional, highly intense, highly monochromatic and highly coherent optical sources. The stimulated emission was postulated by Einstein in 1970. So now coming to the next topic, that is properties of laser. So or we can say that characteristics of laser. So we will start with the first characteristic, that is coherence. The wavelengths which are identical in phase and direction are known as coherent waves. Here in case of laser, all the constituent photons of laser beam possesses the same energy, momentum, and it propagates in the same direction. So we can say that laser beam is said to be highly coherent. Now, next is high intensity. So due to coherent nature, laser has the ability to focus over a small area. So we can say that the laser beam has a high intensity. Next is high directionality. So an ordinary light source emits light in all possible directions, but laser beam travels as a parallel beam over long distance without spreading. So it is an important property of laser. So it is highly directional as compared to the normal beam because it can travel long distance as a parallel beam. Now next is high monochromaticity. So the laser from a normal monochromatic source spreads over a range of wavelength of the order 100 nanometer. But the spread is of order of 1 nanometer for laser. Hence we can say that laser is highly monochromatic. So it can emit light of single wavelength. Now the next characteristic is brightness. So light from laser is much more brighter than other ordinary light sources. And last is laser speckles. So speckles are light patterns resulting from the reflection of coherent light at rough surfaces. So it can degrade the image quality of laser projection displays. It can be avoided by a light source of sufficiently large optical bandwidth. So these are the characteristics, or we can say that properties of laser. Now moving further to the principle of laser. They include spontaneous emission, stimulated emission, and absorption. Now let's start with induced absorption. So here you can see in the figure, if a photon of energy hp is incident on the atom in the lower state, the photon is absorbed by the atom and the atom gets excited to the higher state. So here we can say that before absorption, atom is in the lower energy state. But if we apply external photon to that atom in lower state, the atom absorbs that photon and it excites to the higher state. Here, the rate of absorption R12 is proportional to the population of lower energy level N1 and to the density of incident radiation rho. So here we can say that R12 directly proportional to N1 into rho, where N1 stands for population of lower energy level and rho stands for density of incident radiation. So finally we can say that R12 is equals to B12 N1 into rho, where B12 stands for absorption coefficient. Now, so you have to keep in mind that in absorption, the atom is in lower energy state, and when we apply external photon to that atom in lower energy state, the atom excited to the higher energy state. Now, let's discuss the second process, that is spontaneous emission. By quantum mechanics, the lower energy level is more stable than higher energy levels. So electrons tend to occupy the lower energy level. So those electrons in higher energy levels decays into lower energy level with the emission of electromagnetic radiation. So here you can see in the figure that it is a process in which there is an emission of photon whenever an atom transits from a higher energy level to the lower energy level. Here, in case of spontaneous emission, we have not applied any external photon or external energy to that atom which was in higher energy state. So here, the radiation emitted is equal to the energy difference between two energy levels. The rate of spontaneous emission R21 is proportional to the population in the higher energy level is N2. Here we have not applied any external photon to the atom which is in higher energy state. That's why here we can say that rate of spontaneous emission R21 is directly proportional to the population of high energy level, that is N2. So here R21 is equals to A21 N2, where A21 is the coefficient of spontaneous emission. Now let's move towards the process which is used in laser, and that is stimulated emission. Suppose the atoms of active medium are initially in E2, or we can say that in higher energy level. Now, if external waves with frequency that is near the transition frequency between higher energy level and lower energy level is incident on the medium, then there is a finite probability that incident waves will force the atom to undergo a transition from higher energy level to lower energy level. So here, every difference between that energy level gives out a wave in form of photon. We call this stimulated emission since the process is caused by external excitation. Here in this case, as you can see in the figure, in this process, there is an emission of photon whenever an atom transits from high energy level to the lower energy level under the presence of external energy. So here, when atom is in high energy level, and if we apply the external energy to that atom, then that atom comes into the lower energy level. Here the rate of stimulated emission R21 is proportional to the population N2 at the higher energy level and to the density of the inducing photon. So here R21 is directly proportional to N2 into rho. So finally here the rate of stimulated emission R21 is equals to B21 N2 into rho. Now let's discuss the difference between spontaneous emission and stimulated emission. Now we are aware of both the processes. So let's start with the first difference. So emission of light takes place through an inducement, or we can say that by external photon in case of stimulated emission. Where in spontaneous emission of light takes place immediately without any external energy. Stimulated emission is not a random process, but spontaneous emission is a random process. The photons get multiplied through a chain reaction in case of stimulated emission. Whereas in spontaneous emission, the photons don't get multiplied by a chain reaction. We can say that the stimulated emission is a controllable process, where spontaneous emission is uncontrollable process. In case of stimulated emission, the beam is more intense, where in case of spontaneous emission, the beam is less intense. Here, in case of stimulated emission, monochromatic radiation is there, where in case of spontaneous emission, polychromatic radiation is there. So, in this video, we have discussed the introduction and principle of laser. In principle, we have discussed the three processes: absorption, spontaneous emission, and stimulated emission. So let's quickly revise that three processes or three important sentences related to these three processes. So in case of absorption, you have to keep in mind that atom is in lower energy state, and when we apply external energy to that atom moves towards the high energy state. Where spontaneous emission, atom was in high energy level, without applying any extra energy, that atom comes into the lower energy level. So here we can say that difference between two energy level radiates in form of photons. Now stimulated emission. So in this process, the atom is in high energy level. When we apply external photon to that atom which is in higher energy state, it moves towards the lower energy level and it radiates the photon. So now in next video we will learn about the different constants A and B, which is also known as Einstein coefficient, and we will derive the ratio of rate of stimulated emission to the rate of spontaneous emission. This theory also known as Einstein theory. So that's it for today's session. Thanks for watching.